concept of longitude and time. And so let's begin. Now I want to mention that first of all that the Earth rotates from west to east, and that doesn't look like the case, since we normally see the sun setting in the west, having rose from the east. But the reason is because the sun is stationary, but the Earth is rotating on its axis from west to east. That's the reason why it appears to be moving from the east to west. The other thing is I want to mention is that the places on the east are normally ahead in terms of time, and that is if you compare them with places on the west. Now another thing I need to mention is that in 24 hours the Earth rotates along its axis through an angle of 360 degrees, or a complete circle on that matter. Therefore that means if the Earth rotates through 360 degrees in 24 hours, then in 15 degrees it rotates through it rotates through 15 degrees in an hour's time. And let's mention some few other concepts that are related with this. One is if we have four places like the point P, Q, R, and S, and we know that the Earth is rotating from west to east. Now supposing that an angle difference between the points P, Q, and Q and R and S are all of them 15 degrees, it therefore means that S is ahead of R by an hour. The point S is ahead of R by an hour's time. If for example S is 9 in the morning, it means R is 8, and Q will be an hour later than that is 7, and P will be 6 in the morning. I need to mention maybe that R is also ahead of Q by an hour's time, and Q is also ahead of P by an hour's time. The same way also S is ahead of Q by 2 hours, and you can make lots of conclusions just because the time difference, so that the angle difference between the points is all of them 15, so it's kind of multiples of hours. Now to break this down, that is in terms of calculating questions that have to do with angles that are less than 15 degrees, maybe I need to mention that 1 degree, the Earth rotates through 1 degree in 4 minutes. I've just divided the 15 by 15 and the 60 by 15 also to get that the Earth rotates through 1 degree in 4 minutes time. Now let's use an example to show those things that I've just mentioned there. Number one, the example we have here says that find the local time in the following points, given that local time in London is 18 hours on Monday. And we have 8 questions there. These questions are two different types. There are those whose position is to the east of London, and there are those that are to the west of London. I want us to begin with those that have got that are on the east of London. And so to attempt the question, I'm going to present the diagram of the globe. So this is how the Earth looks like, and we have in the first question we have a place that is 7 degrees east, and so we have that 7 degrees east meridian, and we also have the 0 degrees, that is London. London is normally 0 degrees, and so we have the angle difference implied by this second diagram here. We have, if this is Greenwich meridian, that is where London is, somewhere along this, and you have this other place which is 7 degrees to the east of that, then there's an angle at the center of the Earth implied by those two lines there, and the angle at the center there is 37 degrees. Therefore that means that since the angle at the center is 37 degrees, the point 7 degrees east is ahead of London by 37 times 4 minutes. Remember I said that the Earth rotates through 1 degree in 4 minutes. Therefore the time difference between London and that place given there is 148 minutes, which is 2 hours and 28 minutes. And that therefore means that this place must be ahead. If London is 13 hours, it must be past 13 hours by 2 hours and 28 minutes. Therefore just add and you get the answer is 1528 hours, or if you like 3:28 p.m. I think that's easy. Let's go to a question. We have another place here which is 9 degrees east, and remember London is still 13 hours and it's on Monday. Therefore, having this globe shape here, I want to represent the two meridians. That's the Greenwich meridian and also the 9 degrees east meridian. Now the angle difference between the two of them is 9. Of course, it can also be shown using this diagram that I've shown there. This is the Greenwich meridian where London is somewhere along that line, and this is 9 degrees east, and that's the place we are looking for the time, local time. So again, the angle difference at the center there is 9 degrees, and that means that that place there, this place 0 degrees 9 degrees east, is 9 times 4 minutes ahead of London. Since London is 13 hours, this place must be somewhere past 13. It cannot be before, because they see the sun ahead of those people in London. And that means it's 36 minutes ahead, and so the local time is 13 hours plus 36, which is 13:36, or if you like 1:36 p.m. It is still on Monday. Another thing, we look at another example. We have a place there that is 101 degrees north and 101 degrees east. Now, representing the same diagram that I've just used in the past two examples, I have the two meridians. I have 101 degrees east and again 0 degrees. That's somewhere London lying somewhere along that line there. The angle difference is 101. It's clear now, since I'm just moving this way to get the place that I'm looking for local time. Now again, the angle difference can also be shown using this diagram. I actually think that this is better to show the angle difference. This is a meridian along which London lies, and then the other one, the 101 degrees east meridian. So the angle difference shown at the center of the earth on the plane of the equator, which is 101 degrees. Now I would say that this place here is ahead of London by 101 times 4 minutes, which is 404 minutes, which is 6 hours and 44 minutes. So it means that they must have passed 13 hours by 6 hours and 44, because they're ahead of London. That means you just add 13 plus 6 hours 44 minutes, and it'll be 1944 hours, or 7:44 p.m. in the evening, but it's still the same day. So it's Monday, 7:44 p.m. Let's consider questions that are different from that. And so the first one here is 41 degrees north and 74 degrees west. So this place must be west of London, so they must be getting to 13 hours after London has already had that. So we would say that they are behind. Let's go to the question therefore, and here is the model of the earth again. Now I have switched the meridians. This is a meridian along which London lies, and the other one, 74 degrees west meridian, is that on there. The angle difference is 74, because just to move westwards from the 0 degrees meridian. Again, it's implied by this, the same way we implied in the previous cases. The angle at the center is that angle there, which is 74 degrees. And so we would say that this place here is behind London by 74 times 4 minutes. And that means that that place is behind London in terms of time by 296 minutes, which is 4 hours and 56 minutes. That means before they get to 1 p.m., London will have passed already. And so what time are they? They have 4 hours 56 minutes before 1. And so you just get 13 hours minus 4 hours 56 minutes, and that will be 8:04 hours in the morning, or if you like 8:04 a.m. in the morning. So the calculation is just different by the fact that we just subtracted the hours, because places in the west will get to that point later in the day. Another example that is similar to that is I'm going to use this number 7, 35 degrees north, 105 degrees west. Similarly, we have the model there, and we have the 105 degrees west and 0 degrees east, 0 degrees, that is the Greenwich meridian, and London lies somewhere there. So the angle difference is 105. If I use this model also to show that, I'm going to show you that the angle at the center is 105 in our given case. And so we would say that this particular place here is behind of London by 105 times 4 minutes, which is 420 minutes, and that is exactly 7 hours. So they have 7 hours before they get to 13 hours on Monday. So what time are they? They are 13 hours minus 7. They have 7 hours before they get to 13. So I just subtract that, and it's 6:06:00 hours in the morning. That is 6 a.m. in the morning. And I think that's pretty simple. The whole idea was we look for the angle difference. Again, we change that on in terms of minutes or hours and operate. To conclude this lesson, I want to mention something about number 8. We have the place is 20 degrees south, and 20 degrees south, 20 degrees 40 minutes east. The concept I want to introduce there is something about the 40 degrees east. And so let's look at that. Now, in mathematics, we say that sorry, before I mentioned that, maybe I need to say that for those of you who haven't known this sign we're using here, we normally read this one as 40 minutes, which is, we read it as 40 minutes, which means this, that since 1 degree equals to 60 minutes, then the 40 minutes is 0.67 of a degree. I think I need to say that again, that we read this part here as 40 minutes, which is a measure of an angle, not time. Measuring angle, they are not time. So that's something that you should know. Again, we know in mathematics that 1 degree normally equals to 60 minutes. So 40 minutes will be 0.6 recurring, which I have rounded off to 0.67 degrees or of a degree. I've just divided 60 by 40. Therefore, we can say that this place here, 24 degrees 40 minutes east, is the same as 24.67 degrees east of London. And then we progress as we have done in the previous case. We convert that by just multiplying by 4. So we get this figure here gives us 98.67 minutes, which is 1 hour, 38 minutes, and 40 seconds to be precise. So is it ahead of or behind? Again, the people who are at 24 degrees 40 minutes east must have passed 13 hours by 1 hour, 38 minutes, and 40 seconds. So the answer will be 13 hours, you add that figure there, that's 1 hour, 38 minutes, and 40 seconds, and the answer will be 14:38 hours, 40 seconds. Or if you like, 2:38 p.m. and 40 seconds. And that brings us close to the end of my presentation about longitude and time. I hope you follow. Please check out my tutorial coming just next after this, or I'll be posting the same time. So it will be about speed and shortest distance. So I hope you find it helpful. Thank you.